How are you? My name is Mr. J.M. Kimani. I welcome you to Decision Theory, Lesson 2. Now, in Lesson 2, we are going to feature the environment of uncertainty. Now, in this environment of uncertainty, we have some decision rules. So we have 5 rules. We have 5 of them. The first one being the Maximax criteria. Second one being the Maximin criteria. Third one being the Hurwicz criteria. And the fourth one being the Laplace criteria. And the last one being the Minimax criteria. These are approaches to the environment of uncertainty. Now, Maximax criteria, it is for extreme optimism. Is for those who are extremely optimistic. Now, this Maximax is for those who are extremely optimistic. Now, these are the risk takers, and the large firms or organizations. Now, the concept here is that you become so optimistic, you only feature the maximum you may make, the highest you may make from a decision, and therefore you ignore the rest, which are not the maximum. It is a kind of a decision where we are actually maybe sidelining and avoiding and discriminating some of the other outcomes. So it's only done by risk takers and also large firms that can be able to absorb huge losses should the environment or should the condition that maybe they were banking on not happen. If it backfires, it makes a loss. That big loss can only be absorbed by large firms but not small firms. That's called Maximax. So in short, maximum of the maximum payoff is our criteria. Then we have the Maximin criteria. This one is for extreme pessimism. This is for those who are extremely pessimistic in nature. They are negative in nature. They always see themselves losing. And therefore, it's done by the risk averters and the small firms. Small firms that cannot be able to absorb huge losses. And therefore, they'll choose that decision with a smaller loss or with a minimum which is not a loss. Otherwise, if you choose a decision that has the minimum being a loss, that means you are ready to absorb the loss. They are small firms, they will not be able to. And therefore, it is only for those who are negative in nature. They always see themselves failing, and therefore they would actually use it as a criteria. Then we have Hurwicz criteria. Now, Hurwicz criteria, this is actually, we call it as a criteria of, so criteria of realism. So realism. Now, what this means is that we are realistic in nature because we are not looking at the maximum alone, neither are we looking at the minimum alone, like the optimistic and pessimistic decision makers are doing. In any case, optimistic decision maker will be facing north, while pessimistic will be facing south, and therefore they will not agree, they will not actually agree on a particular decision. They'll always disagree. They'll perceive that decision differently. But to bring them together, we can use the Hurwicz criteria, because this one now takes a part of the maximum and a part of the minimum. They now have the average. That is about the Hurwicz criteria. Then you have Laplace criteria. This is actually it actually considers and assumes equally likely situation where all the possible outcomes will happen and may happen with the same possibility. And therefore, if you have like 3 outcomes, then we'll assume that all they can happen at the same time, and therefore we are going to give a probability over that. If there are 4 outcomes, they're going to assume a 0.25 or a quarter. That's what we mean by are equally likely. Now, one thing to note, it's only the Laplace criteria that tries to change the problem from an environment of uncertainty to that one of risk, because of the probability that you're going to use. But the rest, all the rest, they don't use probabilities, apart from the Laplace criteria. Then Minimax. Minimax criteria is that decision criteria where you are choosing the minimum of the maximum. No rational decision maker would choose the minimum of the maximum profit. No, you cannot choose minimum of the maximum profit. So in this case, it must be reflecting to the losses but not profit. So that now you can choose the minimum of the maximum loss. So therefore, we are going to prepare another table, a table of regret. A table of regret. So that now, from those regrets or the opportunity losses, we can select the maximums, then we settle on the minimum one. That is possible. But now, if it's about profits, then we use the rest. Apart from these 5, number 5, the rest, they use the same conditional payoff table. But for the last one, uses another table, which are calling the opportunity loss table or the regret table. So these are the decision criteria that are used under the environment of uncertainty. And remember, I had explained in lesson 1 that this is an environment where we are not certain of the state of nature, neither can we be able to attach the probability. And it's always identified, it's always maybe, we imagine that we are so new, is a new product, is a new project, so we have no idea concerning it. So we want to act from our, let's say, risk attitudes. Are we positive? Are we negative? That's what we do. So for us to understand all these, we need actually an illustration that is going to take us through and perform all these or make decision on all these. The illustration reads that Zomao Limited is in the process of setting a selling price for one of its products. 3 prices are under consideration: shillings 40, shillings 43, and shillings 44 per unit. The following information is also provided about figures about future demand and the product under different market conditions. There is now the demand in units under the 3 prices. There is a market condition. Now, prices are shillings 40, 43, and 44. The conditions are best possible, most likely, and worst possible. Now, for the best possible, the demand is 18,000 units, 16,000 units, and 14,500 units for the 3 prices respectively. Most likely, the demand is 16,000, 14,500, 14,000 respectively. And for the worst possible, the demand shall be 12,000, 10,000, and 8,000 respectively. Fixed costs are estimated to be shillings 240,000 and the variable cost per unit shillings 20. Required, advise the company on the best possible price to set for the product on the basis of the following decision-making criteria. 1. Maximax decision rule. 2. Maximin decision rule. 3. Laplace decision or criteria of rationality. 3 or 4. Minimax criteria. And 5. Advise Zomao Limited whether it is worth acquiring perfect information, assuming that the cost of obtaining the information is shillings 31.67. End of question. Now, this question, looking at it, it is giving us some various variables. For example, the prices, the variable cost, the fixed cost, the levels of demand. Now, that tells you we can work with all those and come up with one outcome, which automatically must be profit. Then we have also the states of nature, which is our choices, which is our conditions, and these are the market conditions, best possible, most likely, and worst possible. We also have the decision alternatives, which is our choices. Our choices is to choose a price of 40 bob, 43, and 44. That is what we are going to. So therefore, the first task we have is to construct a payoff table. Then we put all this together. Now, our payoff table, just like the way the question is set, we'll be having this way. So this is conditional payoff table. So we have the states of nature, which are the market conditions. And then we have the decision, which is the selling prices, which we have as shillings 40, shillings 43, shillings 44. Then now from there we can have the market conditions. We have best possible, we have most likely, and you have the worst possible. Now this table will be having the columns. We have the price of 40, the price of 43, the price of 44. That is our columns, and that's our table. Now, we want to have the workings. So the payoffs here. Payoffs, this one will be actually profit. And our profits, we have already been given the price, we have the variable cost, we have the levels of demand, and we have the fixed cost. So we need to use this approach to determine the payoff, which is now the profit. So what we are going to do, since we have the profit, the price here, if we take this price constant, we take the price 40 shillings each, and then we look at the variable cost, so 20 shillings, the levels of demand given the question, and the fixed cost. So we'll be having this for the first working. So for shillings 40. So profit will be 40 shillings minus 20, 40 minus 20, 40 minus 20, which we are going to multiply by the respective demands given there. We have been given the demand for the price of 40 shillings, 18,000 units. We have 16,000 units, and we have the 12,000 units, which when you subtract the 240,000, the fixed cost, 240,000 the fixed cost, 240,000 the fixed cost. This now will give us our profit as follows. The margin is 20 shillings times 18. That is going to be 360. 360. You subtract 240. This is going to give us 120,000. The 20 shillings times 16 is 320. 320 minus 240, you get 80,000. And the profit margin of 20 times 12, that is 240. 240 minus 240, you get 0. That's break-even point. So you transfer them here. The profit here is 120,000, 80,000, and 0. That is the outcome if you have that profit or that price. Then if we take the price, shillings 43, then the profit shall be 43 minus 20, 43 minus 20, 43 minus 20, multiplied by the respective quantities demanded. These quantities are, we have 16,000, 14,500, 10,000 units. Then you subtract the respective, the fixed cost, 240,000, 240,000, 240,000. Now this will give us a profit of, the margin is 23. 23 times 16 minus 240. This giving us 128,000. 23 times 14 minus 240. This giving us 93,500. That's 4,500. Then 23 times 10 minus 240. This giving us minus 10,000. Meaning we can come and substitute here. This is 128,000. This is 93,500. And you have the minus 10,000. These are the values or the payoffs you have concerning this price of 43. Then for the price of shillings 44, then the profit shall be 44 minus 20, 44 minus 20, 44 minus 20. So multiply by the respective quantity demanded, given there for their price. We have the 14,500, 14,000, and you have 8,000. We subtract the 240,000 as the fixed cost, 240,000 as the fixed cost, 240,000 as the fixed cost. Then now this one we can multiply and subtract to get the profit. The profit shall be, if you take, this is 24 shillings as the margin, 24 times 14,500 minus 240. This will give us 108,000. While 24 times 14 minus 240, this giving us 96,000. While at the 24 shillings times the 8 minus 240, this giving us a minus 48,000. So we come and transfer here. This is 108,000. This is 96,000. This is minus 48,000. That's all. Now that's how you determine the value you are going to use as your payoff for you to make decision. Otherwise, we could not have used the units. We forget about the price and the cost. Neither could we have used the revenue. We forget the cost, or the cost, we forget the revenue. So therefore, we need to put all those together: the price, the cost, the levels of output or the demand. All those put together, we get now the outcome, which is the profit, and that's how it should be done. Now, it is unfortunate that sometimes as students, you are given such information that and you are unable to comprehend, get to know what is going to be the outcome of such kind of variables. So you ignore others and do not know what to do with these variables. So you are supposed to have some application of knowledge from other topics. Like now, this issue of profit we did in topic 3, where we are doing CVP. We did a whole topic concerning it. Therefore, as a student, you are supposed to have the comprehension concerning all these variables, that if you have them in a question, then the outcome will definitely be the profit, and that's how you're able to determine such. Then, now we answer as per the Maximax, Maximin, and all that. So we are going to have a summary here. We'll have a summary, so that now you're able to make the solution there. So the summary will be having, and this is details. We have shillings 40, shillings 43, shillings 44. The summary is for the maximum profit and for the minimum profit. Now, maximum is where you are choosing that if, for example, like you make this decision of 40 shillings, what will be your maximum and the highest profit? This is now what a risk taker or an optimistic decision maker looks at. Looks at the highest he can make. The highest we can make is 120,000 there. While the lowest for the same decision, in case of a risk averse or either the pessimistic decision maker, is 0 we can make there. The maximum for 43 shillings, the maximum is actually 128, while the minimum for that is negative 10,000. The maximum for the price of 44 is 108, while the minimum is actually negative 48. This is now our summary, so that you can be able to use in the Maximax and the Maximin. So you can now begin. So the first decision criteria is actually Maximax criteria. Now, what do we say about the Maximax? Maximax means the maximum of the maximum. And therefore, we are going to indicate this way. This being the maximums, the highest of the highest is this 128,000. We highlight it, and then now we make our conclusion that the maximum of the maximum profits is shillings 128,000. Therefore, the optimal selling price is shillings 43. So we have now made a decision here, so that the optimal is a price. Shillings 43 is the optimal price. That is our conclusion. Then number 2 is the Maximin criteria. Now, what do you say about the Maximin criteria? Remember, this one is the maximum of the minimum. So in our case, this being the minimums, and you are rational, you cannot go for the worst. So being rational means you have to go for the best. The best is actually this 0, unlike choosing a negative. Therefore, you'll say here that the maximum of the minimum profits is 0. And therefore, the optimal selling price is shillings 40. So here we have chosen shillings 40 as the best. And those are our 2 solutions. That Maximax, 43 shillings is the best. Maximin, 40 shillings the best concerning these 2 that we are highlighting. That is actually something to consider. Now, apart from that now, we can have the third one, number 3. Even though not asked in this question, we have it as Hurwicz. I would want to take you through this Hurwicz criteria. Now, I gave you that Hurwicz criteria is that one which gives an average of these. In fact, Hurwicz gives an average of maximum and minimum. And we normally say that the expected value, which is EV, is given as EV equals to, we have the alpha times the maximum payoffs plus 1 minus alpha times the minimum payoffs. So the formula is alpha times the maximum payoffs plus 1 minus alpha times the minimum payoffs. So we can say here where alpha represents degree of optimism, while a 1 minus alpha represents degree of pessimism. What that means is that in most cases, when you talk of Maximax, we are assuming that you are 100% optimistic. When you talk of Maximin, we assume that you are 100% pessimistic. But in most cases, and in reality, you would be a percentage positive, but you still have some negativity in you. That you are optimistic in nature, yes, but there are some cases where you become pessimistic. You have to be positive and negative at the same time. So we need to apply those probabilities or those proportions. That's why alpha represent the probability of being optimistic, and 1 minus will represent the probability of being pessimistic. In this question, let's assume we assume like alpha is, let's say, 0 point, no, 0 point, maybe 0.65. 0.65. That tells you that you are positive 0.65. You have the guts 0.65. You are fearful, you are pessimistic, of course the other one, which is 0.35. So in this case, if we were to determine the expected value, we'll have this now. This is the price, and this is the expected value. So we'll have this as a summary. So shillings 40, shillings 43, shillings 44. So the expected value will be, we take 0.65, 0.65, 0.65 as the probability of being optimistic, multiplied by their respective maximums. So the maximum we have indicated here as a summary, maximum is 120,000, 128,000, and 108,000. These are maximums. Then we add the degree of pessimism, which must be the opposite. If this is 65, this must be 0.35, 0.35, 0.35, where you're going to multiply with the minimums. Minimums, you also have them here. This is 0. This is minus 10,000. And this is actually minus 48,000. Now, how much do we make as the average? Now, we'll say the first one is 0.65 multiplied by 120,000, of course, plus now this 0, which you get 78,000. Then you do have 0.65 times 128,000 plus 0.35 times minus 10,000. This is giving us 79,700. Then you have 0.65 times 108,000 plus 0.35 times minus 48,000. This is giving us 53,400. Now, of course, we are rational. We have to go for the highest profit, which is now this 79. So we come and say here that therefore, shillings 43 selling price is optimal. With the highest expected value. So look at that. That shillings 43 selling price is optimal with the highest expected value. That's how Hurwicz works. So we have actually considered the same that Maximax and Maximin have considered, on that we have worked with both Maximax and Maximin, and therefore we are able to determine the average of that. And that's how it is for Hurwicz. Then the fourth one, which is Laplace criteria. This one we have said it is a decision that changes the problem from that of uncertainty to that of risk, because we normally have we normally work with the average of all the outcomes. So therefore, the expected value for this one is normally the summation of x divided by n, meaning you sum up all the possible payoffs divided by the number of states of nature. So in fact, you can say here that where summation of x, this is total payoffs, while n represent the states of nature. For example, if you are to have here now the price, and you have to have the expected value, you would have this kind of a summary. So 4 shillings 40, shillings 43, and shillings 44. Now, the expected value means we take the total summation, which of course, if you look at our table, the outcomes of shillings 40 for best possible, most likely, and worst possible, we had 120,000, we add 80,000, we add 0. This we divide by 3 because there are 3 values, all of them, they have possibility of happening. So if you add that, you'll have, this is already 200,000. 200,000 divided by 3 is coming to an amount of 66,667. That is the average of the happenings between 0 and 120,000. 66,667. Then for the price of 43, the outcomes, they are also 3. We have 128,000, 128,000 plus 93,500 plus minus 10,000. This we divide by 3. So 128,000 plus 93,500 plus minus 10. So this is going to be 128,000 plus 93,500. Then we subtract 10,000. This giving us 211,500 divided by 3. This is giving us 70,500 as the average. Then for the price of the 44 shillings, we have the outcomes like 108,000 plus 96,000 plus minus 48,000. This divided by 3. So since they are 3, so this is going to be 108,000 plus 96,000 minus 48,000. This is giving us 156,000 divided by 3. This is giving us 52. Now, these are the averages. And these being the averages and their profits, their incomes. So a rational decision maker will choose the highest. So the highest is this, which is 70,500. So that we can say under the Laplace, the optimal selling price is shillings 43 with the highest expected value. That is all about Laplace. Now you'll note that in the question, the last requirement, apart from the Minimax, the last requirement is asking us to advise on whether the company should acquire additional information if the cost of the information is shillings 3,167. Now, it can only be done using Laplace. Why? Because Laplace is the one that changes the question from uncertainty to risk. And risk is where we determine the value of perfect information. So we are going to use the Laplace to answer that. So how do we answer that last requirement, which is, I think, number 5. So we can have this way. I'm going to erase this part. So to get now the expected value with information minus the value without information. So you have this way. So value of perfect information, VPI, is now what we are asked there as number 5 as per the question. So VPI in lesson 1, I indicated that it is the expected value with perfect information minus expected value without perfect information. So EV with perfect information and EV without perfect information. Now, we'll say here that where EV with perfect information, this we must go back to our table. Our initial table, conditional payoff table, we have information. If we get the information, remember, this is our discretion. We are the ones making decision here. And we need to get the information concerning the market conditions. Suppose we are told it is best possible. Then what are we going to choose? The choice we are going to make is this one of 128,000 being the highest. So you select a price of 43. Should you be advised that it is the most likely that will happen, then of course we'll choose this one that has the highest, which is 96,000. And if we are advised that it is the worst possible, then of course we are going to charge a price of 40 shillings with the best here, which is 0. So what do? With the information up here, we now take them. We say it is going to be the 128,000 plus 96,000 plus 0. All this we add, we divide by 3. To get now this, we are calling the expected value with perfect information. So this, when you add them, they are 3 in number. So it is 128,000 plus 96,000. Then we divide by 3, which is 224. Divided by 3, this will give us 74,667. That is our total amount that we are going to get should we get the information in advance. Now, our EV without perfect information, we can only attribute it to the Laplace. In our Laplace, we selected the price of 43 because it was giving us a value of 7,500, while the rest were giving us a value less than 7,500. Why we are calling this one as without information is because it is taking amounts like 93, which are not the highest. We have 96 here. Taking amount of -10, which is not the highest. The highest is this 0. So therefore, it is without information. So therefore, this is 7,500. So you see that therefore, VPI is going to be 74,667 minus 7,500. And this now will give us a total of 4167, which is more than 3167. So what does it mean? It means, as we are told to advise the company whether to acquire information, we'll tell them, yes, acquire the information, because that information you will acquire will boost your profits by 4,167, though you'll incur only 3,000. So as much as the value is more than the cost, then of course we are supposed to advise them to acquire information. But if the cost would have been higher than the value, there is no need. You have to do a CBA, a cost-benefit analysis. And as long as the benefit is more than the cost, then they are free to acquire information. That's all about Laplace. So I've done Maximax, Maximin, Hurwicz, and Laplace criteria. Now, the last one is the Minimax. Minimax, like I told you, no rational decision maker would go for the minimum of the maximum profits. These can only be losses, that now you can choose the minimum of the losses. So you normally have, so this is now number, let me have it as number 5 as per my counting. This was just the requirement of that question, but as per my number of decisions here, I am having this one as number 5. So this is Minimax, Minimax criteria. Now here we require a table of regret. So we have regret, or otherwise what we call opportunity. Opportunity loss table. Loss table. Now this table will be just like the way the original one is, but with the minimum laboring. So we have shillings 40, shillings 43, shillings 44. Then you can have the opportunity losses and regrets computed as follows. We have, this is our best possible. We have most likely, and we have worst possible. Now we have this, and we are going to have a final analysis here, which is over the maximum loss. Maximum loss. Now it is very, very imperative of you to know how the table is calculated, is prepared. Very, very important. There is no way you would regret if the most likely condition happens and you are waiting for the best possible. It's not by your action, by your discretion, that you are to choose the market condition. So you cannot regret. You can only regret if what is your choice happen to be not the correct choice. For example, if shillings 43 would be the best choice, but you chose 40 shillings, then you can make a regret by comparison. So what you do, from our original table, we are going to compare the outcomes with respect to the prices. If you chose 120, could we be regretting? We can only regret if there is a better outcome than the 120, which is true. If you select 40 shillings, you'll make 120. But you see here, you would have selected 43 and you get what? 128. There is going to be a regret because there is a better than the 120. In a nutshell, we normally take the condition constant and then we make a comparison of these three outcomes depending with our decision. That this is the highest, 128, we'll be regretting if you don't select it. So like if you select this one, we'll be making 8,000 lesser. So that 8,000 become our regret here, 8,000. But should you select 43, you'll be making 128 the highest, and therefore there's no regret. If you select 44, you'll be making 108, which is 20 shillings, 20,000 lesser. This is our regret, 20,000 is our regret. Then most likely, if you compare, this is the best, you cannot regret, but the rest will be regretting. Like for example, 80 against 96, this is 16,000 amount of regret. 93,596, this is amount of 2,500 regret. But here there is no regret, is the best. Then this one, the highest you can make is 0, unlike the negatives. And therefore, if you select 40 shillings and this is the best, you will not be regretting. This will be a 0 here, no regret. But you do select this one and you start making negative 10, you'll be regretting the same 10,000. 10,000 here. And finally, if you make this decision of 44 and you make negative 48, you'll be regretting because you'll be making 48,000 lesser, 48,000. That is the point. Now, having completed the table, then we are supposed to determine the maximum loss. The maximum you can lose here is actually 16,000. That is going to be our biggest worry. The maximum here is 10,000, being again our biggest worry. Well, lastly here, the highest is 48, and that is even the worst. We are not choosing the maximum loss because it's good, no. We are choosing that we can avoid, and so that we can choose the one that has not so much loss. And that's why we have the name Minimax, minimum of the maximum, which is actually 10,000. So what is going to be our conclusion? We'll say there that the minimum of the maximum possible loss is shillings 10,000. And therefore, the optimal selling price is shillings 43. Optimal is 43 shillings. And that's going to be our solution. I hope you have seen how we prepare the table and how we make a conclusion. I have realized that most of the decisions are 43 shillings. So most of them. So Maximax, Maximin, Hurwicz, all those, most of them were 43. It's just a coincidence. So it's not a pattern. It's just a coincidence that 43 seems to carry the day. But I hope now you have seen something to do with those criteria. Something to note, like I told you under risk in lesson 1, that we cannot do EMV and EOR at the same time. because they give the same conclusion. But under uncertainty, these are people who are so different in terms of their risk attitude. And therefore, we can address the same question using Maximax, and you obtain a different solution, unlike using Maximin. And therefore, you can see even the conclusion may be different, and that's how. So, but at the same time, to note something, you cannot be positive at the same time you are negative. You cannot be optimistic, but at the same time you are so pessimistic. So either you belong to Maximax or belong to Maximin. This is how we apply these decisions. That's all about the criteria or the environment of uncertainty with all those 5. Now, to wind up, we can try a simple illustration to wind up that area concerning how to make a decision and how to construct a payoff table. So the illustration reads that George Okech is a pineapple trader at Ukulima market. He buys pineapples at shillings 40 each and sells them for shillings 100 each. He donates any pineapples not sold at the end of the day to a children's home. He has approached you to assist him in determining the number of pineapples that he should buy each day in order to maximize his operating income. For you to give him informed advice, you requested him to give you the average daily demand, which he provided as follows. Daily demand number of pineapples na probability. Pineapples are 0, 100, 200, 300, and 400, while the probabilities are 0.05, 0.2, 0.4, 0.25, and 0.1, respectively. Required. Advise George Okech on the following. 1. The number of pineapples to buy on a daily basis in order to maximize his operating income. And 2. The amount of money he should be willing to pay you to give him a perfect prediction concerning the daily demand. A simple question that we are supposed to construct a table and we make the analysis. So we can have it this way. And to note something, whenever a question has probabilities, then the approach of that question is under risk. Since you can see that under uncertainty, there's no risk. So this one of ours has probability, so it is under risk, which we have done it already in the lesson 1. So you can have here conditional payoff table. Now, one thing to note, when you're preparing the table, you must determine what is the state of nature and what is the alternative decision. Now, this is what is controllable, and this is what is not controllable. In our case, we want to advise him on the level of stock to keep, meaning the supply is going to be our alternative decision, while the demand by the customers, demand will actually now be his state of nature. So you're going to have equal number of columns and rows because the supply and the demand are equal. So you're going to have here. So this, we can say this is our decision. And our decision tumesema ni the supply. So sorry. This is our decision, which is supply, and this is our states of nature, which is the demand. Now the demand, you realize that we have 0, 100, 200, 300, and 400, and they have their respective probabilities. Like this one is 0.05, 0.2, 0.40, 0.25, and 0.10. Then after that, we'll be able to have our EMV here. So this is going to give us our EMV. This is EMV. So this is how the table will look like. Our decision, which is now the supply, also we have 0, 100, 200, 300, and 400. This is going to be our number of rows. So if I indicate these rows that way, these rows, that you can be able to work out easily. Then you have these columns that way, that way. Now, what I want to train you how to determine the payoffs very fast, very fast. Like now this question, you've been given the selling price to be 100, the purchase cost to be 40. That means you're going to make some profit of 60 bob. But in case the demand is 0, or in case the supply is more than the demand, then of course we'll be having donation. We are donating. This is now donation. So if you're donating, then we are going to have a loss of the 40 shillings. Remember, we were buying at 40 shillings. So if we are going to donate, we'll have the loss of 40 shillings. But if you're going to sell, we'll make a profit of 60 shillings. Now, how you calculate this is very simple. So first of all, you imagine if you are buying nothing and you are selling nothing, of course, there's nothing you're going to incur or you're going to earn as profit. Now, should you not have anything, you didn't buy anything, you didn't buy any pineapples, and the demand is 100, you can't satisfy that demand, and therefore you just make 0. So here in this question, there is no what we call the stock out cost or shortage cost like we saw in topic 6. Topic 6 of inventory, we looked at the shortage and stock out cost. So here you don't have such. Otherwise, if there was stock out cost, we would have found this to be negatives, or we'll be making some losses this way. But now this time, it's not such. In case you buy 100 pineapples and the demand is 0, of course, all the 100 pineapples, you're going to donate them. If you donate them, you'll lose 40 shillings per pineapple. So you multiply by 40, you get 4,000 negative. This is a loss you're going to make. But in case the demand is 100 of what you have the pineapples, you'll sell the 100 and you sell at a profit of 60 shillings. Times 100, you get 6,000 as the profit. And that is going to be the same profit across, because if the demand is more than the supply, you cannot satisfy that demand. You can only supply what you have. You continue making 6,000. 6,000. Red pineapples, you'll buy at 40 shillings, you spend 8,000, but you only sell nothing, meaning the whole of 8,000 become a loss. So this is going to be minus 8,000. In case you buy the same 200 units, and therefore you incur 8,000, but the demand is 100, you'll only sell 100 at 100 shillings, which means you only sell for 10,000. So if you were to subtract 10,000 from that cost, you'll make a profit of only 2,000 here. And in case all the 200 you have purchased, you'll sell them and you make a profit of 60 shillings. 60 shillings times 200, that gives you 12,000, and that's what you're going to make across, because the demand, when it exceeds the supply, you only supply what is available. We make 12,000. In case you buy 300 pineapples and the demand is 0, all the 300 you're going to donate them, and therefore the 12,000 you have spent become your loss. 12,000 is a loss here. And in case the same 300 you have purchased at a cost of 12,000, if you are going to sell 100, you'll only recover 10,000. So 12,000 minus 10,000, which you're going to recover, you are unable to recover 2,000. So this becomes minus 2,000. In case you still have purchased the same 300, which means you have incurred 12,000, and the demand is 200, you'll recover 200 times 10, times 100, which is 20,000. So if you recover 20,000 minus 12,000, it means you make a profit of 8,000. And in case the 300 you have purchased have the demand of 300, you sell all the 300 comfortably, and you multiply by 60 shillings to get 18,000 as your profit. 18,000. The same here, 18,000, because you cannot sell 400 and you have 300, so you only get the same profit. Finally, in case you buy 400 and you spend 400 times 40. You spend 16,000. That, the whole of it become a loss if the demand is 0. Therefore, this is 16,000 as a loss. But that 16,000, you may recover it if the demand is 100, because 100, you're going to sell at 100, you make 10,000. So out of 16, you recover 10,000, you are going to have a loss of 6,000. And in case the demand is 200, this time you're going to recover 20,000. So from 16,000, you'll have recovered all the 16 and you make a profit of 4,000. And in case the demand is 300, you'll sell 300 at 100, which is 30K. So 30,000, and you have spent 16,000. That means you'll make a profit of 14. This is 14,000. And finally, in case all the units demanded, no, all units purchased are demanded, or the 400, you're going to make a profit of 400 times 60, which is 24,000. Now, that is how you can determine the payoffs very fast, because we do not want where we are making, we are wasting time and we are unable to take the advantage. Now, finally, we are supposed to determine the EMV. EMV is where we multiply the payoffs by their respective probabilities. Like here, the payoffs are all zeros times the probabilities here. The answer is going to be 0. But this one now, we take the minus 4,000, we multiply by the probability, which is 0.05, plus the 6,000, multiply by probability, which is 0.2, plus the 6,000, multiply by probability, which is 0.4, plus the 6,000, multiply by probability, which is 0.25, plus 6,000, multiply by probability, which is 0.1. So 0.1. This is going to give us an amount of 55. Now, this is the same as, mathematically, taking this minus 4,000, the way it is, minus 4,000, you multiply by 0.05, and then you take this 6,000 as a representative of the rest, you multiply by the probability, these 4 of them, which is giving us 0.95. So 0.95. This gives the same amount. Here, this is minus 8,000 times probability of 0.05 plus 2,000 times probability of 0.2 plus 12,000 times probability of 0.4 plus 12,000 times probability of 0.25 plus 12,000 times probability of 0.1. This gives us 9,000. 9,000 is the expected value. The next one is minus 12,000 times probability of 0.05. Then also minus 2,000 times probability of 0.2. Then now plus 8,000 times probability of 0.4. Then plus 18,000 times probability of 0.25. Then plus 18,000 times probability of 0.1. This is 8,500. And lastly, we have the minus 16,000 times probability of 0.05 minus 6,000 times probability of 0.2 plus 4,000 times probability of 0.4 plus 14,000 times probability of 0.25 plus 24,000 probability of 0.1. This is giving us 5,500 again. Now, these are our expected monetary value. These are the averages of all these. And therefore, as a rational decision makers, we select the highest. The highest is this 9,000 is the highest. And therefore, we make our conclusion that the optimal supply level should be 200 pineapples with the highest expected value. The optimal supply level is 200 pineapples with the highest EMV. Then finally, part B or Roman 2, you are asked to determine the amount of money that he should pay you to give him the perfect information. Again, that is still what we had done here, the value of perfect information, the VPI. So we say here that, so this is Roman 2, VPI equals to EV with PI minus EV without PI. So we say that EV with PI. Remember, we have been saying that it is where you have the information, you select the highest. In our case, if I was to highlight, if I am given the prediction for the demand, remember, this is what we are making choices, but this is the information. If you are informed, the demand shall be 0. Then, of course, the best we can do is to still not supply anything, and therefore, this becomes the best. Such a question where it is demand versus supply, ordinarily, if the demand is 100, the best to supply is 100. If the demand is 200, the best is 200. And that's true. If you look at along this principal diagonal or the main diagonal, you'll discover that this is the one that has the highest and the maximum amounts. For example, if the demand is 100, the best is this 6,000, which is the same supply level. So this is the best. If the demand is 200, the best is this 12,000, which means, again, you supply the 200. If the demand is 300, the best is this 18,000, which shows you that you still supply the same 300. If the demand is 400, the best is 24,000, showing you that you should have produced 400. In this case, we should have purchased 400 pineapples so that we can make the best. Now, that being our best if you are informed, then we got to come and compute here the EV. We say that it is 0, probability is 0.05, plus 6,000, probability is 0.2, plus 12,000, probability is 0.4, plus 18,000, probability is 0.25, plus 24,000, probability is 0.1. How much is this? So if you multiply this, starting with the 6,000 times 0.2 plus 12,000 times 0.4 plus 18,000 times 0.25 plus 24,000 times 0.1. This is giving us an amount of 12,900. That is with information, 12,900. But without, so EV, without PI, this actually is what we found here as the best, and we highlighted 9,000 was the best of without information. So we can see that therefore VPI is 12,900 minus 9,000, giving us shillings 3,900. What does that mean? It means you, as the advisor of this person called George Okech, you cannot charge him anything above 3,900. Why? Because this is the maximum value you are bringing him. You are improving his profits from 9,000 to 12,900 by only 3,900. So you can only charge him any amount lesser than that 9 or maximum that 9. That's what I mean. This being the value, the cost should be lesser. That's the point. And that's how we can answer such a question. And that is all I can indicate concerning the two environments. Environment of risk, we are using the probabilities and all that. Environment of uncertainty, we are looking at the 5 criteria, the Maximax, the Maximin, the Minimax, and using also the Hurwicz and Laplace. In any case, for Maximax, you just take the highest. For example, like in our case, the highest of all these profits would be 24. So if you're using Maximax, then the George Okech would now supposed to purchase 400. But remember, when he has 400, the risk is so high because he can make as low as negative 16,000. It's so risky. So if George Okech is a risk taker, he can take the 400. But if he's not a risk taker, then he should avoid the 400 and buy the quantity that will give him not any loss. For example, here, the minimums are these. This is what is giving us the best. Otherwise, the rest are losses. So therefore, you look at the risk attitude of a decision maker. And that's all about it. So in lesson 3, we are going to look at the decision tree, which is still a continuation of condition of risk, because some other questions or scenarios we cannot be able to model them using a table. We must model them using a tree. And this is the reason. For tables, they only take one set of decision against one set of natures. For example, we have only one set of decision, which is supply, and we have this set of nature. They are only one set. Supposing you are doing a question where we have two sets, like you are deciding on the supply level as well as the price to charge the customers. Suppose you have those two levels, the level of purchases and the level and the selling price. If you have like a 3 or 4 selling prices, let's say you have 3 selling prices, you cannot be able to model that one in this table. It's going to be difficult. But using a tree diagram, you can model, you can have the decision concerning the purchases level and that one of the selling price, all that together. So we're going to use, we're going to do that in our lesson 3. But for now, that is it. Thank you.